what I want to do now is I want to consider the function f of x equals to x to the 1/3. Right, and I want to show that this function, so I want to show this function is not differentiable at x equals 0. So I want to show that f of x is not differentiable at x equals 0. So what I'm going to do is I am going to use the definition of the derivative that follows. I am going to use this definition of the derivative of a function at a point C. So f of c prime, the derivative of the function f at the value c, is equal to the limit as x approaches c of f of x minus f of c divided by x minus c. Okay, so this definition of the derivative of f of x at c at the value x equals c is the same as the other definition we gave. So my function, of course, is x to the 1/3. So let me begin. So I want to take, so f prime of 0, the derivative of the function f of x is 0, okay, is going to be the limit as x approaches 0 of the function f of x, but f of x is x to the 1/3, right, minus 0 to the 1/3, right, and of course I am dividing this by x minus 0, and of course you can actually conclude immediately that this is just equal to limit as x approaches 0 of x to the 1/3 x to the 1/3, okay, divided by x. Now why is that? Because 0 to the 1/3 is just 0. The cube root of 0 is just 0, and here we just have x. So this really, after simplification, is just equal to the limit. This is just equal to the limit as x approaches 0 of x to the 1/3 minus 1, right? So far so good. And of course, if you simplify this, this is equal to the limit as x approaches 0 of 1 over x to the 2/3. Okay? So now we want to see what this looks like. As x approaches 0, let's see if this has a limit. Well, this is really what this really is over here is just a limit as x approaches 0 of 1 over, okay, the cube root of x squared. Okay, 1 over the cube root of x squared. Now this is an even function, and it's not difficult for me to actually graph this function, because as x gets very, very, very large, this actually is going to approach 0, and it's even, so I can actually tell you what the graph looks like. This function is an even function. When x equals to 1, this is just going to be 1, and as x gets closer to 0, this is going to shoot up. Well, it's very easy to graph this, but rather than doing it here, what I'm going to do is I'm going to go to wolframalpha, since I already have a very good idea of how to graph it, and I'm going to just ask it to plot it for me, and that's what I'm going to do. So I'm in wolframalpha right now. So here is the graph of this function. So I issue the command in wolframalpha, plot the function y equals to 1 over x squared to the 1/3. And of course, this is it here. So this is plotting the function y is equal to that. Of course, I didn't have to write y equals. In wolframalpha, you can get away with just typing what y is equal rather than writing y equals a function of x. So here is the plot, here is the graph rather, of this function. Now as you approach 0, okay, from the right, notice that this is shooting up. The function is shooting up. If you approach 0, okay, from the left, the function is shooting up. So the limit, so clearly the limit as x approaches 0 of this function is going to be equal to infinity. And that is really what we were looking to show. In other words, this function over here, f of x equals, okay, to x to the 1/3, doesn't have a derivative at x equals 0. Okay, so the function is actually not differentiable. And if we were to graph this function, which we are going to do right now, you will notice that when x equals to 0, the tangent line at the point 0, 0 is actually a vertical line. In other words, it has undefined slope, because vertical lines have undefined slopes. So let me actually graph this function so that you can see that. Alright, I am going to graph it. So I'm going to plot the function x equal, okay, y equals to x to the 1/3. So I'm just going to do this, and I'm plotting the function, and I am going to issue the command y equals. Okay, I could do that with no problem. This is telling wolframalpha to plot for me the function y is equal to x to the 1/3, okay, which is the function that we were working with over here, okay, as you see. Okay, so I'm issuing this command in wolframalpha. Now, as I said, I don't actually have to write y equals. I can just write x to the 1/3, and wolframalpha will know which function I am talking about. So this is the graph of the function of the -2 to 2, but this is actually not correct, because the cube root of a negative number can be taken. Okay, and of course you see over here that the tangent line at the point x equals to 0 is actually a vertical line. Look at it over here. It's actually a vertical line. Let me actually copy this image and paste it over here. So I'm going to paste this image over here. Okay, so here we have the graph, the real graph. I mean, the plot of this function, of the graph of this function. And you notice that when x equals 0, this claims that it's giving me the graph from -2 to 2, but it's actually not true. So wolframalpha is actually wrong here. But I know what the graph of this looks like, because this function happens to be, okay, this real value function happens to be symmetric about the origin. Okay, so so that all I have to do is just rotate this by 180 degrees. This graph I rotate it by 180 degrees, and I get the actual graph over here, which should look basically like this over here. But it doesn't matter. Over here I can see, and let me actually make this clear, that the actual tangent line is actually a vertical line. And you know, of course, that the slope of vertical lines is undefined. So that is why this function that we were working over here with, x to the 1/3, is not differentiable at x equals to 0. Okay, thank you for listening.